Okay, let's take a look at this. Got f of x is equal to e to the negative 5x squared. For our relative min, relative max, we need to find our derivative. Well, the derivative of e to any power is e to any power times the derivative of the power. Derivative of negative 5x squared is negative 10x. To find our critical values, we set this equal to 0. Now, e to a power can never be equal to 0, so I can drop it, and I got negative 10x equal to 0, or simply x is equal to 0. Clear over here is positive infinity, clear over here is negative infinity. I'll pick test cases. Something less than 0 like negative 1, something greater than 0 like 1. Now, e to a power is always positive, so I don't need to worry about plugging into that. I just need to worry about plugging in negative 10x. So I got negative 10 times negative 1, which is positive. And I got negative 10 times, that was negative 10 times a negative 1, which gives you positive. Negative 10 times positive 1, which gives you a negative. So this is increasing and decreasing. So this is a relative max. Now we would take that 0, plug it back into our original function. 0 squared is 0 times negative 5 is 0. E to the 0 is 1. So our max is going to be 0, 1. Okay, now our derivative is negative 10x e to the negative 5x squared. To find our second derivative for inflection point, we're going to use the product rule. This will be p, this will be q. P prime, the derivative of that is negative 10. For q prime, we already found the derivative of e to the negative 5x squared over here. It's going to be negative 10x e to the negative 5x squared. So our formula is p prime q plus p q prime. So for our second derivative, p prime is negative 10 times q, which is e to the negative 5x squared, plus p, which is negative 10x, times q prime, which is negative 10x e to the negative 5x squared. Now I can factor out an e to the negative 5x squared, and that leaves us negative 10 here. And negative times negative is a positive 100x squared. Okay. Now if I set that equal to 0, again the e is always positive, that can never equal 0, so we'll work just with this. So I got negative 10 plus 100x squared is equal to 0. Take negative 10 over, it becomes a positive 10. Divide both sides by 100. And we get x squared is equal to 1 over 10. Yeah. Drop our squared, put a plus or minus square root around the other side. Square root of 1/10, or square root of, 1/10. Is 0.32. I guess they take it to 2 decimal places there. So those are our critical values. So we're going to have x equals negative 0.32. We'll have x is equal to positive 0.32. Clear over here is positive infinity, clear over here is negative infinity. We want to pick test cases. Something less than negative 0.32 like negative 2. Something between negative 0.32 and 0.32 like 0. And something greater than 0.32 like 1. We want to plug these into our second derivative, which is right here. Don't really need to plug into this first part though, because that's always positive. So we just plug it in this piece. Negative 10 plus 100 times negative 2 squared. Negative 2 squared is 4 times 100 is 400 minus 10 is positive. So positive means this is going to be concave up. If I plug 0 in, negative 10 plus 100 times 0 squared, that gives me a negative, which is concave down. If I plug in a 1, I got negative 10 plus 100 times 1 squared, which gives me a positive, so it's concave up. So this is a point of inflection, because the point of inflection is where the concavity changes, inflection point. And you take these 0.32 and negative 0.32 and plug them back in the original function to get these 0.61s.